So we'll look at a simple clustering technique like k-means. So in k-means there are four main steps available. So the first step is we pick a k number of clusters. So that k number of clusters will be picked randomly, and then what we do is, for the given data set we will calculate the distance for each data element for all the cluster centers. Then after calculating, we can assign each data element to the nearest cluster by considering a particular distance function. So then after that, we move each cluster center by taking the mean values of the assigned data elements. Then after that, we will repeat this step 2 and step 3 until all the cluster centers values will be the same. So that means the cluster centers are stable. Then we can stop this particular algorithm. So to understand the k-mean clustering clearly, we'll take a simple example like this. So here we have 8 data elements A1 to A8, and the initial cluster centers are given as A1, A4 and A7. So in this example, the initial cluster centers are given to you. So if the initial cluster centers and the number of clusters are not given, then you are free to select any random number of clusters or cluster centers. The distance function is also given, and we need to find the three cluster centers and the data belongs to it after the second iteration. So initially what we need to find, we can have it in a table like this from A1 to A8, and also the initial cluster centers are also given. So using the given distance function, we can determine the distance for each data element to each cluster center given. So for an example, when we consider the first point, we know the first point and the cluster center, and then we can use the distance function, as you can see here, to determine the distance. So after determining the cluster's distance for each data element, we can store this in the table. So same way we can calculate for the second point based on the available cluster centers and calculate the distance, and we can save all the values in the table for each data element, the distance for each cluster center. So from this we can determine what is the cluster for each data element, and then after that we can calculate uh, the number of data elements for each cluster, and after determining the data elements for each cluster, then we can take the mean value for each cluster. So for the first cluster we only have A1, so therefore the mean value would be the same. For cluster 2 there are 5 data elements, so we can calculate the new cluster center by taking the mean values for the available data elements. For cluster 3 there are 2 data elements, so we take the mean value. So now the new cluster centers will be replaced by its mean values, and then again after replacing the cluster centers by its mean values, we do the calculation again. So using the same distance function, we can calculate the distance for each cluster center for the data element, and again we can determine the cluster for each data element. So uh, after the after considering the cluster centers, again we take the mean value. So that would be the answer for this particular question. But if you want to continue, this can be continued until the cluster centers become stable. That means the mean values are the same again and again. That means the cluster centers are stable. So we can stop this clustering algorithm at that point.